Howdy, AP Pre-Cal. It's Miss Kosh. I am working through the notes created by Miss Vicki Carter. I think the other was one video, I don't remember. But now we're going to talk about how she teaches the complex numbers. And I think it's great. Okay, so a complex number in the complex plane can be determined by the rectangular coordinates a comma b. And you know what? I didn't write it quite like this in my notes, but I saw an AP classroom problem just like this, where they didn't write it as a plus bi. They wrote it like they were doing the problem basically 3 plus 3i is what I saw in AP classroom, but they wrote it as the coordinates 3 comma 3. Okay, that's fine. So anyway, be aware that when they talk about rectangular coordinates, they're connecting AB to this A plus BI, because we graph this where the x-axis is the real and the y-axis is the imaginary. I have seen this called the Argand plane, or the complex plane. That will work too. Okay, so we can connect the Argand plane, the x being the real component and the y being the imaginary, to the polar plane. And so they have something like this: 2 minus 2i. We came over 2 in the real direction, down 2 in the imaginary direction. We end up here. And what this is this is now, can you see this triangle? If you have 2 and then negative 2, this is a 45, 45, 90 triangle. And so this, the hypotenuse or the radius there is going to be 2 root 2, which shows up here. And then the angle, we have negative pi over 4, which is fine. If you had said 7 pi over 4, I'd be happy with that too. We'll see. I can't imagine that AP Classroom or the College Board would give you both correct answers. But so this is the r times cosine of theta plus I sine theta, which we often abbreviate to, we would say this as r cis theta. And if we use her version, that's a negative pi over 4. Okay? I'm lazy, I mean efficient, and so this is a pretty common practice of taking this expression and condensing it down to cis. Notice here's the cosine, and then the I, and then the sine, and that's where those letters come from. Okay, express the complex number in the form this is our cis theta form, but expanded out. Okay, so what I might do is say, okay, negative 3 is the real part. Negative 3 root 3 is going to be more than that. So this is, here's the negative 3, here's negative 3 root 3. Which tells me that this is a 30, 60, 90 triangle, that this is the 30-degree angle, and then this is the 60-degree angle, because it's this number times root 3. Oh, I went in the wrong quadrant. Did you catch that? Oh, okay. Hang on. Wrong quadrant. I was just testing you. Okay. Negative 3, root 3. This is still the 30-degree angle opposite the negative 3, and this is still a 60-degree angle. I just was in the wrong quadrant. Okay, so the opposite, the 90, is twice the size, so this is 6. And then this angle becomes, if I come that's 4 pi over 3. Okay, so we can, if we want to write it in her form, this is 6 cosine 4 pi over 3 plus I times 6 sine 4 pi over 3. That is the answer. Okay, but it might, based on hers, I would say, I would write this as 6 cis 4 pi over 3 because I'm lazy, I mean efficient, and there we go. But let's double check and make sure that we did this correctly. So 6 times, well, cosine of 4 pi over 3 is negative 1/2, plus I times 6 sine of 4 pi over 3 is negative root 3 over 2. Multiply, that's negative 3, plus I times negative 3 root 3. And yes, that is where we started. All right, good luck, go practice, subscribe, let me know how I can help you.